So we're talking about hyperbola today. And hyperbola is a shape that we talked about a little bit when we talked about parent functions. It was that equation that kind of looked like this. And we called that the reciprocal function as well, and it looked a little bit like this. We're going to do something different. Our hyperbolas are going to look like either like this or like this, either up and down or left or right, but the same kind of idea. And they are kind of like the opposite of an ellipse, okay? And so that's the important part right now that you need to know about the hyperbola. Okay, so I'm giving you this. It seems super overwhelming, but we're going to walk through it step by step together. This is just like, the basics of a hyperbola. Like when I'm looking at a hyperbola, what do I know? Okay. First it says find the lengths of this axis. So this is just to get us used to this idea of the hyperbola. The box really helps us draw the hyperbola out. It's just a different kind of conic section for us. Okay, so when we're looking at this hyperbola that I gave you, and the actual graph of the hyperbola with all the stuff on here is this chunk here and this chunk here. And the rest of it is just to help us draw it. Like if we typed this equation in, you would only see those things that I have in my blue right now. So I want to know the length from A to B. So let's count that. So that was 1, 2, 3, 4, 5, 6. So that total length from A to B would be 12. Okay, and then let's try C to D, and I'll do a different color in that one. 1, 2, 3, 4. So this is also 4, so that distance here is 8. So just like we were talking about ellipses last week, remember I drew the center, and we can see where the center of this one is, right at 0, 0. And then I drew my lines out, and then I drew my lines up, and that is how I then, last week, right, I used these dots to make an ellipse. Okay, we're doing a hyperbola, which, like I said, is like the opposite of an ellipse. Okay, so then let's think about, just like in our ellipse, what is the distance from A to the origin, which is our center? And we said it was 6. We counted it out. And then I want to know, how about C to the center? We said that was 4. Okay, and just like in our ellipses, these numbers are going to use to tell us which side's the big side, which side's the short side. Okay, so it's the same picture on the next slide. Go ahead and pause me if you need to. Okay, exactly like our oval, our ellipse, we have vertices and co-vertices. So because it was longer in the x direction, what color did I have? Purple. Our vertices are here. And if I count, I think this is -6, 0, and then this is 6, 0. Okay. So -6, 0, 6, 0. This is from exactly above. I counted these, remember? We counted and we got 6 and 6. Because 6 is the bigger number between 6 and 4, 4 being our up and down direction. The bigger number is our vertices and tells us which way it opens. The smaller number is our co-vertices. So I go over 0 up 4 and over 0 down 4. Okay, so just like an ellipse, because 6 is bigger, that's my vertice. 4 is smaller, it's my co-vertice. Same as an ellipse. The shape starts to change though. Okay, same picture again, exact same picture again. Okay, I'm going to draw it in. This is my hyperbola. This is my vertice, and these were my co-vertices, and this was my center. Look at this equation. X squared over 36 minus y squared over 16 equals 1. Check it out. Just like our ellipse, the bigger number tells us where our vertice is. 36, the square root of 36 is 6. Oh, guess what? That was our vertice. our vertex. And 16 is the smaller number. Our co-vertex had a distance of 4, right? Square root of 16, okay? So far, we're just like an ellipse. I hope what you notice is different, though, is in an ellipse, right, this was plus. In an ellipse, it was plus, and all those things we did made our oval. In a hyperbola, all these things we'll do will make two curves that look like sideways parabolas, right? So now I've got an equation for you, and I am saying like, oh, a hyperbola has vertices at 3, 0, so over 3 up 0, back 3, so negative left 3 up 0, right? So that was a distance of 3. And then I'm saying co-vertices at over 0 up 5 and over 0 down 5. Okay, so the first thing that you need to ask yourself when you're looking at this is which side is longer? Which side is bigger? The side that I did in orange here, each of these were 5, and the side I did in black and I'll highlight it in blue was 3 and 3. Okay, so up and down, our vertices are going to go under the y, 5 squared, 25. Okay, this will be an up and down hyperbola. And in the other direction, 3 and 3, 3 squared is 9. Again, this is a lot like ellipse. If you felt good about ellipse, it's very similar. We just have a minus now. So the next is the math definition of a hyperbola. If a hyperbola has vertices at this A in the x direction and B in the y direction, then here's its equation. Just like the circle and just like the center, you can imagine that our center is going to be there. Okay? It's a little different though. The center h comma k happens with if the x is first, it's like we're used to, right? Like it's our h comma k, okay? Though if it's going to be an up and down box that we're going to draw, if it's going to be an up and down hyperbola, right? That's for this hyperbola. If it opens left or right, the x is first and the center looks just like we thought. Just like the circle. So I'll write it like a circle or our ellipse, our oval. I spell it wrong. I think it has 2 L's, okay? What happens if it wants to open up and down? Opposite of our tall ellipse, okay? Then the y comes first. And our center is still h comma k, but you just need to be a little bit like open your eyes, you know, like look, investigate, inspect. The h is still next to the x and the k is still next to the y, but they traded places because the y is bigger. And that's how I know it opens up and down. So that's kind of like the trippy part of this. It's going to trick you a little bit. So as we go through these, we'll have to remember, look for the x first, look for the y first. Okay, and that'll help us with the vertices and co-vertices. Okay. I'm going to stop the Edpuzzle here. You're done watching. And then I'm going to continue and I'll put the full answer key up for those of you that want to do your homework.